All right, question number 5. Refer to problem 4. If the sample size were increased to 400, what effect would this have on the width of the confidence interval? Okay. Now, the width of the interval is directly tied to the margin of error, right? The bigger the margin of error, the wider the interval is. So let's calculate the margin of error with this new sample size of 400. Okay. So with 400, our degrees of freedom would be 399. Confidence level still 95%. Okay, so 399. All right, there is no 399. So we're going to go all the way down to 100. Okay, so we'll be using 1.984. Now, that's really not that different than 1.990. I mean, the difference is in the second decimal place. So for the most part, that's not going to have much of an effect. 1.984. Okay, 1.984 times 2 over root 400. Okay. All right, so again, this is the margin of error that we're calculating. 1.984 times 2 divided by root 400, and you get 0.1984. Okay. Now, in question 4, this was approximately 0.4 if we round, and this is approximately 0.2 if we round. Okay. So the margin of error is about half the size as it was in the previous question. All right, so looking at option B here, the width of the interval would be cut in half. Okay, so generally, if you quadruple the sample size, the interval will be half as wide. Okay, the reason why it's not a fourth as wide is because this is in a square root, right? So root 400 is equivalent to saying root 4 times root 100, and root 4 is the same as 2. Okay, so we're introducing a factor of 2 in the denominator, so that's cutting the margin of error in half.